This is Shakil Ahmed. In this tutorial, we will discuss about analyzing categorical data when we have two or more categorical variables and we need to check the association or we need to compare the prevalence across the groups. So the most basic statistical inference is to conduct a chi-square test to see whether there is an association between the two qualitative variables, or even we can see the prevalence of any outcome in exposed and unexposed group or in different groups. So we will start again with this strokes data that consists of different variables, the mixed type of variables, qualitative and quantitative variables. We just start with a contingency table. We uh, read this data from CSV format, and then we need to import the pandas as PD as we have already imported. We don't need, and then we need to import the chi-square contingency from the scipy stats library. So we just run it, and then the contingency table. You need to just from pandas library, you need to use the cross tab and then the two variables, the two quantitative variables. I just want to see whether the strokes prevalence is different in different work type, people belonging to different work types. So we can just see a cross tab and also print the contingency table, but that we have discussed in our earlier lecture. In probably in lecture 1 and 2, and perform the chi-square test. So this is just chi-square contingency and then the table you got using the cross tabulation command. And then we are getting three things: the chi-square value, that is the statistic, and the p-value, and the degree of freedom. And if you want to see the expected frequencies, then you can also print expected as well, but I am not printing this, just focusing on the p-value and the chi-square value. It's giving some error. So see, you can include, well, but you don't need to print. If you don't want the expected value, just uh, print a dash here. Then you will get the chi-square statistic, that is 49.16, and the p-value is 5.39 raised power minus 10. That is a strongly significant association between the work type and strokes. And then you can find the odds ratios, but in this case we have uh, more than two groups of exposure variable. That is we have four to five work types, so we can compare different work types with the reference category. For example, I tried to compare the private the odds ratio for I computed the odds ratio for private and then odds ratio for the self-employed, and then compared the odds for private and then odds for self-employed, and then computed the odds ratio for self-employed versus the private. So we can take one category as binary and then compare, or just create two categories and then compare. For example, private and others, then you can compare them. But if you want to compute odds ratios for all the groups, then you need to create the odds for all groups and then compare the odds ratios. So the odds of private stroke odds of others, you can compare others as and private just using this command, and then odds ratio for private to uh, ratio for private work to other types. You can just find the other ratio, the odds ratio, and you can generate this for other groups. But for now, I am just skipping this. If you want to create, we can just create here text, and then we can copy this and we can find this like that. So odds ratio for private work type having a stroke is 1.1. That is 11% higher odds of having strokes for those who work private as compared to other work types. So this is the interpretation of the results. We can odds ratio for private work type having a stroke is this. So right example, right, the odds of having a stroke is 11%. You can just write this percentage and 'let's see. So it's you just need to subtract odds ratio by 1. So it will give 11%. It will give, and you can just multiply it by 100. Want to write in terms of percentage. See, so it's 11.9% higher in the private group as compared to the others. So you can just interpret your result like this. And if this ratio is less than 100, less than 1, then you need to do the same thing. And that is, for example, if the odds ratio is 97% or 80%, then you can suggest 20% decreased or 20% less in the uh, private as compared to the other. You need to write that. In that case, you need to just subtract 1 minus the odd ratio and then uh, write lower in the private group as compared to the other group. Let's see, we can check in the we can compare the self-employed versus the other groups, the private. Just compare. So the odds ratio for a self-employed work type having a stroke is 1.92. So it is its comparison with the other groups. Again, it's comparing the self-employed versus the other group. It's again higher in the self-employed group. The stroke rate is higher. And then now you want to interpret your result using the p-value. Right. Yeah, you set your alpha and you can just say reject the null hypothesis that there is no significant association between work type and stroke. This is overall p-value, basic association between the two groups. And then if we have less than 5 frequency in uh, less than uh, greater than 20% of the cells, then we need to apply the Fisher-Exact test. And you can also check in which situation we can use Fisher-Exact test. And I have already discussed the Fisher-Exact test in my previous video. So you need to create a contingency table, and then you can find the Fisher-Exact test. Here I am just checking whether there is an association between residence type and stroke. Usually people living in rural areas have maybe have higher chance of having a stroke than people living in urban area. You can compare this using a chi-square test, but here is we have a 2x2 table. Residence type has also only two categories and stroke has only two categories. So we can just apply the Fisher-Exact test, and the odds ratio is we can find the odds ratio and p-values, and we can again check the p-values again 0.05 threshold, and this is the p-value for Fisher-Exact test. And if the odds ratio is 1.15, it means there is a higher chance of having a stroke in the urban. We need to check the residence type. If you can just check the residence type is urban, and just check whether it's taking urban as the response, urban as 1 and rural as 0, or rural as 1 and urban as 0. If you are not sure, then you need to create your own dummy variable and you can check. So maybe uh, is 1 and rural is 0, then the odd ratio is 1.1. Higher chance of strokes in urban as compared to the rural. So that's all about the Fisher-Exact test. In next video, I will discuss the binomial test and the McNemar's test for uh, testing the association between quantitative variables, certain problems. Thank you.